Hey everyone, and welcome. Today, we're going to break down Leetcode problem 1935, called Maximum Number of Words You Can Type. It's a really good problem for practicing basic string manipulation and how to use the right data structures to make your code more efficient. Let's get into it. Alright, so here's the core idea. Imagine you have a keyboard, but some of the letter keys are broken. You're given a sentence, which is just a string of words, and another string that tells you exactly which letters are broken. Your mission is to figure out how many of the words in that sentence you can successfully type out from start to finish. So we get two pieces of information. First, the text. That's our sentence. And second, the broken letters, which is just a list of all the keys that don't work. Our job is to return a single number, the total count of words from the sentence that we can fully type. This is the most important rule. A word is only considered typable if all of its letters are working. If even a single character in a word matches one of the broken letters, then we can't type that word, and it doesn't count towards our total. It's an all-or-nothing deal for each word. Let's walk through the first example. The text is, "Hello world," and the broken letters are A and D. First, we take the word hello. We check its letters, das couple, nai 12 times triquus btz, das couple, forky waro. None of these are A or D. Das couple, porper of D, my debrate, my 12 times, das couple, hale wishix, das couple, my 12 times tri-couple. Next we look at the word world. We start checking, W, O, R, L, A, O, D, A. Breakwa. The D key is broken, so we immediately know we can't type world, A. We don't even need to check the rest of it. So our count doesn't change. After checking all the words, our final answer is 1. Here's another quick example to make it super clear. The text is Leetcode, and the only broken letter is E, ena. We check the first word, li, ena. Right away we see it contains an E, so we can't type it. Our count is still 0. Then we check code, gochbeke. It also contains an E, so we can't type that one either. Since we couldn't type any of the words, the final answer is 0. Okay, so how do we turn this logic into a plan? It's pretty straightforward. First, we need to break the sentence up into individual words. Most programming languages have a simple way to do this. Then, we'll go through these words one by one. For each word, we need a way to check if it's clean, meaning none of its letters are on our broken list. If a word passes our check, we just increment a counter. That's really the whole high-level plan. Now before we write the code, let's think about one small improvement. For each letter of each word we need to check if it's broken. We could loop through the broken letters string every time, but there's a much better way. We can convert the broken letters string into a hash set. Think of a set as a magical, super fast checklist. You can ask it, is this letter in you? And it gives you the answer almost instantly, no matter how many broken letters there are. This will make our solution much more efficient. Alright, here's the full solution in Python. Don't worry, we'll break down exactly what's happening on the next few slides. But you can see the main ideas we just talked about. Creating a set, splitting the text into words, and then looping through them to count the good ones. Start at the top. First we take the broken letters string and turn it into broken_set. This is that optimization we just discussed. It makes checking for broken letters super fast. Next we use the split method on the text string, which cuts it up wherever there's a space and gives us a list of words. Finally, we initialize a variable called count_0. This is what we'll use to keep track of the typable words. Now for the main part. We start a loop that goes through each word in our list of words. For each new word, we start by being optimistic. We create a flag, let's call it can_type_word, and we set it to true. Then, we start a second, inner loop, to check every single char inside that word. In this inner loop, we do our check. Is this character in our broken_set? If it is, our optimism was wrong. We immediately set our flag, can_type_word to false, and, very importantly, we break. This stops the inner loop, because once we've found one broken letter, there's no reason to check the rest of the word. After that inner loop finishes, either by checking all letters or by breaking early, we check our flag. If can_type_word is still true, it means we never found a broken letter, so we can add one to our count. So how efficient is this solution? The time complexity is big O of n, where n is the total length of the input text. This is because, in the worst case, we have to look at every single character in the text once. Creating the set also takes some time. but it's proportional to the number of broken letters. For space, the complexity is big O of m, where m is the number of broken letters. This is because we need a little bit of extra memory to store our broken underscore set. Overall, it's a very efficient solution. So to wrap things up, the key to this problem was breaking it down into manageable pieces. First, get all the words. Then, process them one by one. The biggest takeaway is probably how using the right data structure, in this case a hash set, can make your code so much faster and cleaner than searching through a string over and over. And finally, using a simple flag variable is a great pattern for keeping track of a condition inside a loop. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.